This is the steering servo out of our sailboat, and it is just one of the pieces of the autopilot system. And a new autopilot system is a few $1,000s, I think $3,000 or so. But this actual steering servo works just fine. It's just that the brains of it does not work right. So I wanted to see if I could build an autopilot that would be running using an Arduino and a magnetometer sensor, and in this case it uses a display to give us some status. It's got a couple buttons and things, and then it uses a motor driver to basically engage the solenoid that basically turns the ability for the piston to move on and off, and then also can run the piston forward or backwards to steer the boat. And so I could just do this on my own and it would take me some time, and I thought, hey, let's try some chat GPT and see what that can do for us. And it's pretty amazing what it's able to do and how quickly it's doing it. So real quick, just back up here, I started off by telling it to use pieces of hardware, this particular magnetometer, and it just kind of made up code, and it referred to the magnetometer, and the code didn't work, and it was clear that it didn't actually know that piece of hardware, and ChatGPT kind of made up fake code for what it thought was fake hardware. I don't know. So what I did was I found some demo code for this magnetometer, and I gave it to ChatGPT and said, here's an example of code that detects the X, Y, and Z, and then generates the azimuth and the deviation and a few different things. And then I said, now from that, create this software, and boom, it did it. Same kind of a thing. I told it to be able to display. At first, it was just displaying it on the serial monitor, so it was showing it, on the computer, and it would keep on like scrolling, and that's great for testing right now, but that's not going to be so great in use on a boat. So I said, use a 16 by 2 LCD that I have, and generate the code for that. And so I did that, and it basically, again, made up code, and it really didn't make any sense. Perhaps it was doing code that was for some other specific display or LCD, but it was really kind of strange. So I basically wired it up to the Arduino using an example sketch that I had that explained, what all the pinouts should be to just display some text on the screen and have a potentiometer to change the brightness. And then I gave that to ChatGPT, and I said, here's some example code that makes the display work. Now modify this autopilot so that way it displays information on there, and boom, it did it. So the next, same kind of thing. I told it to use the motor controller. I gave it examples of the code, and it seems to be now doing that. At this point now, I'm starting to add functionality. So I've got it so that way it has 2 buttons currently, one to engage the autopilot and one to disengage it. And so what it's supposed to be doing is, right now, it's supposed to be, when you first boot it up, it will basically keep telling you, or let me just turn it off here. So when it's not engaged, it should say autopilot ready, and the heading should be whatever the current compass heading is, which it calls the azimuth in the demo code. So as I move this back and forth, it should be giving me a compass reading right there as an integer, and it's not. And when I engage the autopilot, at that moment, whatever whatever that azimuth was, that current heading, it should now save that as the course. That is where we want to go, the direction we want to go. And then the deviation should be how many degrees to left or to right the boat is actually headed at that point, away from the intended course. And previously I told it, to basically move the servo one way or the other, depending on the direction that the error is. And just a minute ago, I described that I wanted it to be proportional. So, and I made up a formula that it now uses, which is that I don't see here, but basically it was there it is. The speed, no, that's not it. But the speed that the motor goes is based off of a sensitivity that I would be able to adjust later for how sensitive it is. And it multiplies the deviation, the amount of the deviation times the sensitivity. So if the deviation is 1 degree off and the sensitivity is set to 100, then the speed of the motor would be 100. And so between 0 and 1,000 is basically off or full speed. And so what that does is if the boat is 1 degree off, it'll do a 10% of the maximum speed of the motor to correct it back. And if the boat is 10 degrees off course, it's going to move the steering wheel at full speed in the direction to make the correction. And the idea is if every time the boat had to make a correction, it pulled the motor really hard one way or the other, the boat's going to be constantly watering back and forth. But if the boat's only off by like a degree in one direction or the other, it's going to do a tiny little correction. And so one of the other things I'll do is that's sensitivity. One of the other things I'll probably add in there is the allowable error. So that way, if the boat is off by like a degree, it'll just keep doing that. And then if it falls off by the second degree, then it'll correct it back to the original course. But initially, it doesn't really correct if it's only off by like 1 degree. I'm thinking of doing that so that way the servo's not constantly moving back and forth. It'll save a little bit of battery because it does use a decent amount of power to run this servo motor here. But in any case, so where I'm at right now, I said there seems to be a problem, which is basically right now the course on line 1, I told it to use this layout where it was a course and then it gave me the variable set, the current value and the deviation in the current value. And I said, that in line 1 it always shows 0 and that the deviation in line 2 always shows 0. And I reminded it that the course should be what the azimuth reading was when the autopilot was engaged, and the deviation should be the number of degrees away from the course that the current azimuth is reading, or the current azimuth is. And I'm not even using the proper term. I'm sort of hacking. My language isn't all that clear here, but it seems to be pretty amazing what it does. So let me just show you real quick here. I'm going to go ahead and submit it. And whoops, gotta scroll up here. And apologies for the oversight. To correct the issue and display the correct course and deviation values, we need to update the code. And then so here's the modified version, and it's currently generating it here. And the code is long enough that it usually stops partway through, and it will have a continue generating code button to continue. So let me just. It's going fast enough that I can't quite see if it's doing it correctly or not, but. So continue generating, and I'm going to let it finish. So there's that calculate the speed based on the deviation. The speed is the absolute value of the deviation times the sensitivity. That's that formula I couldn't think of a minute ago that I kind of made up as my logic for how to steer based off of a sensitivity level. And while it's generating the code, I'll probably put in something like a potentiometer or maybe a rotary encoder so I can adjust the sensitivity on the fly rather than having to break out the laptop and type something where it's going to be really difficult to do on the go. Okay, so now it's done. It says please upload the modified code. Let me know if you encounter any further issues or have any questions. So I'll go back up and copy code. And then I'll just come back down to the sketch that I was working in, and I'm just going to select all and delete and paste. And let's see now, I'm not even going to bother to verify. I'm just going to upload it, and let's see if it gives us any errors. Compiled just fine. It's done uploading. Okay, so now it's running. Autopilot ready, so it's on standby. So right now when it's doing this, the second line is supposed to read the current azimuth or the current heading that the boat is facing. It doesn't seem to do that until after it comes back after standby, after it's been in use, but I could probably tell it to correct that. But when I press this, so now it says that the course is 0, 0, 0 for some reason. And if I rotate this, no, it's still not working. So you can see this light did come on. So right now the servo is engaged. I can't move it. It's holding tight here. And if I manually press the button, you can see I can override it by manually pressing the buttons on the speed controller, but when I turn this and I basically make that magnetometer spin on the z-axis, it should be steering back and forth as if the boat is off course, and it's not for some reason. So now when I press this this disengage button, you'll see, and now it goes back and it says autopilot ready like it did before, and the heading should be reading the current compass, compass reading, and it's not. So I'm not sure. I got to figure out why it's not working. It did before, it worked before, and now it's not. So I think what I'm going to do, and this is where GPT doesn't seem to be perfect, but it is really useful, is I've been saving versions of this stuff that it spits out along the way. And so it doesn't always get everything, it often doesn't get things right, but it does come up with clever ways to do things. And so in a previous version, it did some parts of this correct, and now it's doing other things in an interesting and, kind of a efficient way. So what I'll do is I'll go back through the code from before, and I'll pull the part out where it was generating the values that I liked, and then I'll say, use this method to, to get this. And the previous thing that I just did was I reminded it what I wanted it to do logically. This variable should be this reading, but I didn't tell it what the actual code was to find that reading. So now I'll go back and do that. But yeah, it's pretty interesting. This is not something that I've done before, using sort of AI assisted coding. In some ways, it's more difficult because I am not making the changes each time. I'm telling it what I want, and it's making the changes, and then I just drop them in, and then I see what happens next. And sometimes it'll make the change I asked for, and then, this is a long enough of a sketch that I'm not going to notice another line somewhere in there that got changed if there's some random other line that got changed. And so sometimes it does other things that it shouldn't have done, and that throws things off. So it doesn't always get everything right, but it does come up with some clever ways to do some of the things that I wouldn't have thought to do. And ideally, in the end, I will have the good ideas that I have combined with the interesting approaches that it has, and hopefully it will be a workable autopilot. And then what I'll do is I'll put it into a little Pelican case, and that way it will be the screen hopefully will be visible through the plastic case, so that way I don't have to worry about getting wet. The other thing I'm going to do is, right now I just currently have one button to disengage it, one to engage it, one to disengage it. I'm going to add 2 more buttons, basically to alter the current course. So once I set the course, if I want to go on this particular compass heading, ideally, and the way this particular Raymarine brand autopilot used to work, if I'm going along in the boat and there's, let's say, something in the water, some debris or a crab pot or a log or something, I could just click -1 and it'll turn the new heading, or the new course I should say, to 1 degree to the left of where it was. Or I could say +1, or I think you could also do like +5 or +10 for bigger jumps, but it has a couple of buttons to adjust that course that you want to go. And so I'll add 2 buttons on here, so that way I'll be able to, tap to do the same thing to the left or to the right, or I can tap a couple of times to do multiple degrees of change in one direction or the other. And then the next thing I'll do when I get that working is I bought a couple of these little inexpensive remotes. And interesting thing is I got a pack of like 2 receivers and 4 transmitters for like $20 on Amazon, so it's not a bad price. I'm not sure if these things are going to hold up, but the cool thing is that these can be paired. Any of the 4 of these can be paired to any of the 2 of these receivers. So if I'm on the boat and I've got this and I ended up dropping it in the water and it gets toasted because it's definitely not waterproof, I have 3 other ones that I could just basically grab one and pair it, and I will have a new remote. And so with this 4-button remote, each of these buttons is a momentary button, and when you press it, it activates one of these relays, and then when you release it, it turns the relay off. And so for each relay, let me see here. If I can get something to point with here. So for each relay, it's got I'm not sure why it's labeled this way, but I'm pretty sure that the center one is the common pin, and then one side is the normally open and the other one is normally closed. So when you press the button, the center common pin will connect to one side, and then when the button is not pressed, it'll be by default connected to the other side. So you can use it in a couple different ways. You can use it to basically turn something off, by momentarily disconnecting, or you can use it to turn something on by momentarily connecting it. And it doesn't hold the button down. It just basically, when the button's pressed, it turns the relay. It's the same as pressing a momentary button. But that's the beauty of this, is I don't want to use switches that are, like a rocker switch that will stay in a position, because if I do that, then the problem with that is I have to override a physical switch if I want to use something like a remote. So what this will do is when I turn this on, it's a push button switch that changes the this status, in this case, whether the autopilot is engaged or not. But because the button does not remain in an on or off position, it just momentarily turns on or off, I can also have it so that way at the same time these 4 relays are connected to the same points on the microcontroller. And so what I'll do is I'll have the 2 smaller buttons down here be the engage or the disengage for the autopilot, and then the big buttons will be the 1 degree left or 1 degree right. And what that'll let me do is I could be basically hanging out up on the bow of the boat, where I can be kind of relaxed and leaning up against the cabin top, looking out over the water. And if I'm moving along, looking out in front of the boat, and I see something in the water, I can basically just say, boom, go left 1 degree or go left 3 degrees or whatever, and I can avoid something that's in the water and not have to run back to the boat and make an adjustment. And then if for some reason I need to stop the boat from using the autopilot, I could just disengage it from here. I might come up with something else. I might come up with a toggle where when you press one button, it will engage and then disengage. And then I could have another one where it will do something custom, maybe like a man overboard function. I can figure out something. I don't currently have a GPS integrated here, but if I did that, I could have an integrated GPS where basically what this is not doing is it's not tying into the throttle or anything like that. And it doesn't know if I'm sailing or motoring. But if you were motoring and you hit a man overboard button, you could have it do something where it would see where you were with the GPS and keep steering and motoring back and doing circles automatically around a point, to basically let a single-handed person do other things like run around grabbing flotation to throw out, getting a line to throw to somebody, while the boat basically doesn't go so far away from the person that you lose sight of them. I guess you do have the danger that the boat could potentially run over the person. But in the situation where it's either lose the person in the ocean at night, or potentially come too close and have to worry about hitting them, I think maybe the worrying about hitting them is probably the preferable one over to they're gone in the distance at night. So just some other ideas for some functionality that could be put in there. I don't know, I guess not all that stuff is figured out at this time. Initially, I just want to be able to tell it to hold a course, stop holding the course, and let me manually take over. And just to kind of point out what this is doing, in case for anybody who's not familiar with this kind of steering servo, it's a linear actuator that's it's got a motor in here that will push this back and forth, which I just showed that a second ago. But when you want to steer the boat manually, this is not giving. It's fixed, right? So it's not until you turn off the autopilot that it basically stops the motor controller from holding this engaged. So when that solenoid is turned off, I'm able to just basically push this back and forth and steer the boat, and it's just spinning the motor one way or the other internally there. And so, if once I re-engage it again, now all of a sudden it's not movable. So, that's why you need to be able to have an easy way to disengage the autopilot, or else you might want to steer the boat and you're just not going to be able to move this thing. This thing is strong enough that you're going to break something in the process. So very worst case, if this thing goes haywire and for some reason it doesn't work properly, all I have to do is just reach into the hatch and turn off the breaker for the 12-volt power that will power all of this and that. And once the power is gone, once I turn off the power, then you'll see the solenoid disengages and there's nothing holding. It actively has to have power for this to be engaged. So it makes it, a little bit safer, so that way I can't lose the ability to steer the boat. I just need to, if this was to go haywire, I just need to cut the power to the autopilot system. So I'll check back in when I have maybe some more progress, but I just wanted to share the interesting approach to trying to code an Arduino sketch using ChatGPT as a sounding board for ways to accomplish some of these different functionalities and things like that. Signing off.